hopefully. Like what I said before, that I assume you have had trigonometry in the past. That's the prerequisite for this class. So this formula are formulas that you have seen before and supposed to have used before. So what I do here is to review that how to use them again, okay, and bring it up to the level of precalculus to prepare you for calculus. Okay, now these are the formulas. I hope you have this handy, because I will need to make my my screen go down here and then do some examples. Let's say, for example, I do number 4. So on page 595, on number 4, cotangent S is equal to 2. And S is between pi to 3 pi over 2. Pi and 3 pi over 2. Basically, it is in quadrant 3. And the question is, we need to find the sine 2s, cosine 2s, and tangent 2s. The cotangent S is 2, so tangent S, the reciprocal is 1/2 in quadrant 3. Tangent S hat will be still 1/2. And then I do the right triangle. So I purposely get the reference angle to help me with the right triangle. Tangent of that S hat here is 1/2. So this is square root of 5. Okay. Now then from there we see, oh, then sine S hat will be 1 over radical 5. Now can you tell me what is sine S then? Positive or negative? That's negative, right? Because S is in quadrant 3. Okay. So negative 1 over radical 5. Cosine S hat is 2 over radical 5. So cosine S will be negative 2 over radical 5. Again, because it is in quadrant 3. Now the tangent, we already have them. Now part A, for that number 4. Part A, find sine 2s. Sine 2s. Now then you look at the formula. Sine 2s is 2 sine s cosine s, which is 2 times negative 1 over radical 5 times negative 2 over radical 5. That's positive 4 over 5. Part B, find cosine 2s. Cosine 2s. Now for cosine double angle, there are actually 3 formulas, and you need to memorize all 3 actually. Okay. Now, since we get the cosine and sine, then you actually have the freedom to use any one of these 3. Okay. But suppose, for example, I only have sine s, then I will use the third formula. If I only know cosine s, then I will use the second formula. Okay. So let's say this one, I use the second formula, 2 cosine squared s minus 1. That will be 2 times negative 2 over radical 5 squared minus 1. That is 2 times 4 over 5 minus 1. That would be 8 over 5 minus 1. That's 3/5. for part C. How about tangent 2s? Tangent 2s, well, we can use what we already have up there. For example, we can use sine 2s over cosine 2s, right? We already have that. Then there will be 4 over 3. Or you can use one of the formula here. You can use the formula here. That's the first method. The second method, you can use the formula. Tangent 2s is 2 tangent s over 1 minus tangent s squared. Tangent squared s. This is 2 times 1/2, right? That's tangent s up here. Okay. And then over 1 minus 1/2 being squared. So that's equals to 1 over 1 minus 1/4. That's 1 over 3/4. That's 4 over 3. Okay, so we get sine double angle, cosine double angle, and tangent double angle. Now, suppose out of creativity, suppose instead I ask you to find secant 2s instead, then what you will do, you will find cosine 2s first, and now you get the reciprocal. Okay, so that will be 1 over 3/5, that's 5/3. Okay, in case I ask you something outside of sine, cosine, tangent. Now that's why you see secant, cosecant, and cotangent of double angle will not be provided because we just need the sine, cosine, tangent of double angle. Okay, now let me use the same question here in number 4, and I will just continue with a half angle. Suppose I want to do part that's now part E. Find where is S over 2 located? What quadrant is S over 2 located? Now, you see that S was in quadrant 3, right? It's in quadrant 3 between pi to 3 pi over 2. When I divide by 2, what quadrant will that be? There will be pi over 2 here. This is 3 pi over 4. That's between 90 degrees and 135 degrees. Now, which quadrant is this S over 2 located? More than 90, less than 180, that's in quadrant 2. Now then, using that, suppose I go on find sine of S over 2. Find sine S over 2. Then, according to the formula we have for sine half angle, it should be plus minus square root of something, but the plus minus there, you need to adjust with the quadrant. In quadrant 2, sine is positive or negative. In quadrant 2, S over 2 is in quadrant 2. Sine of that S over 2, therefore, is positive. Okay?
I have a question, please.
Uh-huh.
Yeah, cos 2s, the formula is 1 minus 2 cos square s. So put 2 cos square s minus 1.
Repeat it again.
The formula of cos 2s is 1 minus 2 cos square s, right?
2 cosine squared S minus 1.
Yeah,
Uh-huh.
yeah. Oh, isn't it 1 minus 2 cos?
Oh, should be, what did I write?
No, here is fine, but go down, you put this. 2 cos square minus 1. And up you put 1 minus 2 cos square.
Which one?
Cos 2. Wait,
Here?
yeah.
Yeah, 2 cosine squared theta minus 1.
Oh, okay.
Number three is I don't think is that how it's supposed to be. Number three, A.
3a?
Yeah, is the bottom? Shouldn't it be 2? The
No,
denominator.
no,
Oh, okay.
no. That's correct. Well, because you just divide sine over cosine. Then the radical 2 cancel. Right? Okay, then, so yeah, because the angle is in quadrant 2, so sine of that angle is positive. Now I plug that in. This is square root of 1 minus, what is cosine s? Negative 2 over radical 5. Negative 2 over radical 5. Let me multiply the top and the bottom by radical 5 inside the radical. So I get square root of 1 plus, actually radical 5 plus 2 over 2 radical 5. I think I should multiply by another radical 5, huh? I multiply by another radical 5. This is just to rationalize the denominator, especially inside the radical sign. So this is square root of 5 plus 2 radical 5 over 2 times 5, that's 10. Now then, to bring that 10 out, I will multiply by 10 over 10 again. So I get 1 over, like the bottom becomes over 100, right? The bottom here becomes over 100. Okay, so that becomes square root of 50 plus 20 radical 5 big over 10. Okay, and I think that's the furthest you want to go. I'm actually okay if you leave it here. If you leave it here, I'm actually okay. Yeah, just don't make it decimal. Don't make it decimal. Try to rationalize as much as you can. Okay, but if you see this question in the textbook, then they will answer it this way. Now, can you try for cosine? For cosine part G, cosine of s over 2. Because s over 2 is in quadrant 2, then cosine value is negative. Square root of 1 plus cosine s over 2. Okay, now again, I need you to memorize this formula. I need you to memorize this formula. I will not forgive you if you don't memorize this. Okay? I need you to memorize this formula. Okay. Let's say you say, Thomas, when I look at the book during the test, I should be fine. You will not know anyway, fine. If you want to do it that way, fine. Okay, but here's the thing though. I can really tell if somebody don't memorize the formula because you will confuse this here. They look very similar. Okay, and I do expect you to know how we actually get the formulas here, as at least you're supposed to know all of them. Okay, and these two formulas here is actually coming from these two. That's how we derive it. Okay, that's how we derive it. So this formula we have here derive, when you derive, you get from double angle formula becomes half angle formula. And there's something being done in between. I explained that in my trigonometry class lecture video. I will not repeat that here. Now, then from here, I go on, continue from this question.
Up for a minute.
Hello?
Yeah, please, can you go up for a minute? I want you to-
You can see this in your book, actually.
Thank you, it's fine.
Uh-huh. Mm-hmm. Yeah. Now, then just plug in numbers. Cosine S is what again? Negative 2 over radical 5. So this becomes 1 minus 2 over radical 5 over 2. Okay, now of course we do not accept complex fractions. Okay, that's why then I would like you to multiply by radical 5. That's how we get rid of the complex fractions inside the fraction. And we don't accept radical on the denominator. That's why I multiply by another radical 5 on the top and the bottom inside the fraction to give me square root of 5 minus 2 radical 5 over 10. Now you see that I actually have this situation right now. Okay, you actually have that situation. Then to get rid of that radical 10, rationalize that radical 10 at the bottom, I multiply by radical 10 over radical 10, and that gives me square root of 50 minus 20 square root of 5, like that. Now, using these ideas that I present to you here, okay, I assume you have your book open with you. I would like you to do question number 10. Number 10, we have cosine theta equals to 2 over 5. And theta is in quadrant 4. And then the question is find sine 2 theta, cosine 2 theta, and then sine theta over 2. And let me add to it, instead of cosine theta over 2, let me change that to tangent theta over 2. Okay, try. I give you 1, 2, 3, 4, 5, 6. 6 minutes from now. Yeah, you keep working on that. I will start working on this too.
Professor, can we do this one that you're doing right now? Can we write it as equal cosine 2 sigma equals to what is it? Cosine power 2 minus sine power 2?
Yeah, you can.
Oh, okay. Thank you.
Part C, I need to decide which region or which quadrant is the sine located, the theta over 2 located. So let me first say that theta is in quadrant 4, therefore theta is between 3 pi over 2 to 2 pi. So when I divide by 2, this is pi, this is 3 pi over 4. In other words, theta over 2 is in quadrant 2. Now then, we can say sine theta over 2 will be positive of square root of 1 minus cosine theta over 2. So that's 1 minus, what is cosine theta? 2/5. So this is 2/5 over 2.
Professor, quick question.
Uh-huh.
Why didn't you also do that same method that you did in C for A? Like you multiplied the quadrant that a 2 theta will be in. Is it because you're not asking for it, or?
No, you don't need to, because we can get the plus minus. I mean, the formula for sine 2 theta is fixed.
Yeah.
The sine for 2 theta is fixed, but for sine theta over 2 depends on the quadrant.
Oh, thank you.
So this is square root of 5 minus 2 over 10. That's 3. And you multiply by square 10 over 10 further. So that will be 1 over 10 square root of 30. That's for part C. Now part D, for tangent half angle, you can see up here for tangent half angle, there are actually 3 formulas. I do not really expect you to use the first variation, this formula here, because you need to decide which quadrant the theta over 2 is located if you use this formula. Now part B and C, however, these 2 formulas, you don't need to, because the plus minus of this later on is basically decided by the formula. Whatever the value you get from there, you get the positive, you get the negative. Okay. Now, in other words, because theta over 2 is in quadrant 2, we do expect when I use a formula, let's say I use 1 minus cosine theta over sine theta. I expect that my final answer for this will be a negative number. Square root of 21 over 5 multiply the top and the bottom by 5. That will give me 5 minus 2 over negative square root of 21. That's negative 3 over square root of 21. Right? Let me rationalize a bit further. Square root of 21 on top, square root of 21 at the bottom. I get negative 1 over 7 square root of 21. Now, that's for tangent theta over 2. Now, another use of what we have here, another use of what the formulas we have here, one of them is, another example, is to compute, for example, sine, this, I take this from number 16, 16a, sine 165 degrees. 165 degrees is half of 330 degrees. Okay, now then 165 is in quadrant 2, so sine is positive. I use half angle formula, square root of 1 minus cosine 330 over 2. And cosine 330 over 2 is positive radical 3 over 2. So I'll multiply the top and the bottom by 2. That will give me 1/2 outside. Square root of 4 at the bottom, I bring it out to be 1/2. Square root of 2 minus square root of 3. Okay. For some strange method that I don't think I know how to teach you, can I do that over here? No, I think I will just leave it like that. Okay, now that's for sine 165. You can apply the same similar thing for cosine 165. Okay, you can try to do it yourself. But I guess I would like you to apply one of the formula for tangent. Tangent 165 degrees. I would like you to apply to using either one of the formula up here. I think I will use the last one. I prefer the last one actually most of the time. 1 minus cosine 330 degrees over sine 330. Okay, let me give you maybe 1 minute to do this. This is 1 minus radical 3 over 2 over negative 1/2. Multiply the top and the bottom by 2. Get 2 minus radical 3 over negative 1. Or simply radical 3 minus 2. Okay. And by the way, tangent 165 is in quadrant 2. So radical 3 minus 2, if you use calculator, you will find that to be negative. Okay. Now, furthermore, the one that you need to be pretty strong with is the following. You see this type of question a lot in my old test. For example, express sine 3 theta in terms of sine theta. Thomas, I don't get you. I don't get this question. Well, maybe I rephrase it then. Basically, let's say suppose I say if sine theta equals to x, then find what is sine 3 theta. You see? Okay. So basically, that's the similar question. Now, how do we do that? Solution: sine 3 theta. That's why I asked you to look at the proofs. Sine 3 theta is, I can rewrite that 3 theta as 2 theta plus theta. And then I will rewrite that as sine of sum of angle, sine 2 theta or sine theta minus, actually plus, cosine 2 theta sine theta.
Professor, are we using the formula that says the addition formulas?
Yeah, I use angle addition formula.
Okay, thanks.
And then from there, so let me write this down. If you follow the grouping I did last time, this is group 1, 3. That's the formula I use. And then right now I will use formula 2, 1. I'm sorry, 2, 2. And then on the right hand side, I will use formula 2, 1, C. Okay, so 2 sine theta. Thomas, I don't know what you're talking about that 2, 2 and 2, 1, C. 2, 2 is this. Group 2, number 2. That's 2, 2. Now 2, 1, 3, 2, 1, C is 2, 1, C. Okay? Now then, so continue. So sine 2c is 2 sine, sine 2 theta is 2 sine theta cosine theta times another cosine theta. Let me mark it so that we can keep track of what I did. Okay. Now for cosine 2 theta, there are 3 formulas I know. Okay, but I will use the formulas in which that we only use sine theta, and that is 1 minus 2 sine squared theta times sine theta. So Thomas, why do you use the third variation instead of the first or the second? Well, because I want to express everything in terms of sine, remember? Right? Because I want to express everything in terms of sine, then I use this formula. Okay? What happens if I use another formula? Well, you will eventually get it anyway. Okay, but it may take longer time. Let me go on. This will then be 2 sine theta cosine squared theta minus distribute the sine theta minus 2 sine cube theta. So everything is okay except this one guy here. I don't like this one because this is not in terms of sine yet. What do you think I will do? And I will use B21. Don't worry about it. You memorized that already. You don't even need to memorize the name. That's basically 1 minus sine squared theta. Then I distribute 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube theta. That will be 3 sine theta minus 4 sine cube theta. Okay. In my old test, I usually ask about sine 3 theta or cosine 3 theta. Cosine 3 theta is actually done in our textbook. That's why I don't do it anymore. Okay, cosine 3 theta is actually done in example 3, page 591. Now, this sine 3 theta is one of the questions in on page 596. Now, another important material from here, especially to prepare you for Precalculus 2 later on, is something called power reduction method. Power reduction. So basically, suppose I have sine squared theta. Express sine squared theta in terms of sine theta or cosine theta or multiple angles without power. Now then you need to think about which formula you have above that has sine squared theta. Now, one of them, actually not one of them, the only one you have is cosine 2 theta equals to 1 minus 2 sine squared theta. Now then rewrite this as sine squared theta. So 2 sine squared theta will be, imagine if you move this to the left becomes plus, and then you move this to the right becomes minus. There will be 1 minus cosine 2 theta. So sine squared theta is 1 minus cosine 2 theta over 2. What happens if I change the question now into express sine to the 4th theta in terms of trig functions without powers. So we will not use, for example, any sine to what power? No, we will not use that. Any cosine to any power? Cosine to any power? No, we will not use that. We'll just use sine or cosine of multiple angles if necessary. Sine to the 4th theta can be seen as sine squared theta squared. And then I apply double angle formula inside the power reduction. Okay, so that's cosine 2 theta over 2 being squared. I get this here to be like this from here. Okay, and then I go on. Let me take the half square out, becomes 1/4, and I will FOIL the one in on the numerator. So 1 minus 2 cosine 2 theta plus cosine square 2 theta. However, we are actually fine with the first term and the second term, no more powers, but we still have power here. We have power here.
Can we write it like as cosine -1?
Repeat it again.
Can we write it again as cosine power 2 -1? Oh wait, no, never mind.
Now
I
then,
just realized the question. Yes.
yeah, then I want to do power reduction again on this cosine square. Now we have a formula that cosine squared blah equals to 1 plus cosine 2 blah over 2. Where do you get that, Thomas? I get that from double angle formula for cosine. So 2 cosine 2 blah equals to 2 cosine squared blah minus 1. So I add 1 to both sides and then divide it by 2. Okay, that's how we get that formula. So that's the formula I will use, except that instead of using blah, I will use 2 stars there. 2 theta, so 2 cosine 2 theta plus 1 plus cosine what? Or theta over 2. Okay, so let me factor the half out. So this will be 3 minus 4 cosine 2 theta plus cosine 4 theta. Okay, let me give you the reason behind this, reason why you need to know this. Because in calculus 2, one thing you need to do is to integrate, for example, sine to the 4th x dx. Now, don't worry, I don't expect you to know how to do this. Okay, now the thing is, for this to happen, before you actually integrate this, you need to re-express this guy here. We need to re-express that to, you need to re-express that into no power trig function. Dx. Okay, so basically you need to do what I just did for you earlier, and then you can integrate.
Professor, a quick question.
Mm-hmm.
You factored out the 2 from there. Why is 3 the first number you get?
Oh, okay. See, this is 1/4. This is, I take the 1/2 here, so it becomes 3/2.
Okay, I see. Thank you.
Right. Okay. Then I factor another 1/2 out. That's how I get that. Okay. Now, our textbook has this question. Number 30. Basically, you have cosine to the 6th theta. Okay, and then express that without the powers of trig function. Express this cosine to the 6th theta in terms of trig functions without power. Now this one will be long. This one will be quite long, as I know. Instead of letting you doing that, let me show you this again. So cosine to the 6 theta, I will rewrite that as cosine squared theta cubed. Okay. And then this is equal to, you can actually use this formula here. You see, this one, it comes from here actually. But what you do is you isolate this guy. You see what I mean? Okay. Now then, coming back here. So this is 1 plus cosine 2 theta over 2 over 2. That's what cosine squared theta is. And then take it to the power of 3. Okay. The 2 to the power of 3, I bring it out, becomes 1/8. Okay. And then what happened is the guy inside, I will extend. I will expand it. I will FOIL it. Okay, so that will be 1 plus cosine 2 theta to the power of 3. That's 1 over 8. Parentheses. 1 plus 3 cosine 2 theta plus 3 cosine square 2 theta plus cosine cube 2 theta. Now, I'm good with the first two terms. But this guy here, let me use this color. This guy here is something I need to change. Right? Okay, so there will be plus 3 times. What will that be? One plus cosine, double the angle over 2. Okay, and then plus, I actually have the similar thing here. I actually have cosine squared here, right? I actually have cosine squared here. But let me leave it for now. Let me leave it like that for now. Cosine cube 2 theta. Okay, and then I will rearrange, combine like terms. I get 3/2 here plus, I'm sorry, not 3/2, my bad. 3/2 plus 1 is 5/2. That's actually 5/2, not 3/2. Yeah, I'm talking about this guy here. This guy together with this guy. Okay. And then 3 cosine 2 theta plus 3 over 2 cosine 4 theta. Okay, so I'm done with the first three terms. I wonder how about the last term here? What should I do with the last term here? Honestly, I don't know. Honestly, I don't know. I can write it as cosine square 2 theta times cosine 2 theta for now. How will that help? I don't know.
We can write the cosine 2 sigma as, can we write it as cosine power 2 negative sine power 2, or the 1 negative 1 minus sine power 2?
You can, but let me hypothetically do it here. So this is 1 minus sine square 2 theta cosine 2 theta, like this.
Yes.
Right? Okay. The thing is, I will still have trouble here. I will have later on sine square 2 theta cosine 2 theta. I still don't know what to do with that.
Okay, I see.
You see? Okay. Yeah, I still don't know what to do with that. And then later on we say, oh, do 1 minus cosine squared again. Then we go back. Right? Yeah, we go back to what we had earlier. So
Yeah.
I think what I will do is, I will just go ahead with my plan that I will rewrite this the same way I did this one here. Okay? So this will be 1/8 and then 5/2 plus 3 cosine 2 theta plus 3/2 cosine 4 theta plus 1 plus cosine 4 theta over 2 cosine 2 theta. Okay, and then furthermore, this is 1/8, 5 over 2. Let me do more combination. I will combine this guy here with this guy here. Okay, so 3 plus 1/2 is 7/2. Plus 3/2 cosine 4 theta plus cosine 4 theta cosine 2 theta. Now the last step here, unfortunately, I need to borrow from something we should have learned in the next section. But you can see this formula. I know it sounds really not really fair that we borrow from the next section, but if you have your book open, on the same page, look at page 585. So I'm not the one not fair, the textbook. Okay, on page 595, on the top box, we see the product to sum.
Yes, the long ones.
Okay, and you will see product to sum formula part C. Okay, that's what we will use. That's what we will use. Okay, that's what I will use. So I will use that there later on. So that's 1/8, 5/2, 7/2 cosine 2 theta plus 3/2 cosine 4 theta plus. Now, if you have your book, please read for me what will that yellow part be if you use that formula.
One, 1/2
1/2 and then
cosine of 2 sigma.
that's not sigma, that's theta. Cosine sum, right? The sum is 6 theta plus cosine difference plus cosine 2 theta.
Oh, okay. Now, I thought that we were going to put them separately, but now it's okay.
You can distribute the 1/2 later on, okay? But then if I continue, this is 1/8, 5/2 plus. Now then I get this again. I have 1/2 cosine 2 theta together with 7/2 cosine 2 theta. If I add them, becomes 8/2, right? Cosine 2 theta plus 3/2 cosine 4 theta plus 1/2 cosine 6 theta. If I factor the 1/2 out, becomes 1/16. Then I will get 5 plus 8 cosine 2 theta plus 3 cosine 4 theta plus cosine 6 theta. Okay. But yes, I have to admit that somewhere in between, I need to borrow from something you're supposed to have learned from, well, you're supposed to have learned this from trigonometry, but in this textbook, they actually do use that in 8.3. Okay. I think it would be helpful if you actually memorize this angle reduction formula. I mean, power reduction formula. Power reduction formula. So for example, sine squared theta, that's equals to 1 minus cosine 2 theta over 2. While cosine squared theta is 1 plus cosine 2 theta over 2. And both both actually come from cosine squared theta. I'm sorry, cosine 2 theta formula. Formula for cosine double angle. Okay. Now, of course, there are some proofing that you should practice to do, but let me just list them as suggested homework. 8.2, I would like you to do number 1 to number 23, just do every other odd. Okay, and then did I do sine to the fifth? Yeah, I did sine to the fifth. Okay, so I would like you to try doing number 31. And then 35. I did sine to the fifth earlier. Number 41 is good. How about 45 and 47? And 49. I'm actually so tempted to try number 47 though. Let me try number 47. Number 47. Prove that 2 sine squared 45 degrees minus theta equals to 1 minus sine 2 theta. Proof. I think I will do it from left hand side. Yeah, because left hand side seems to be more complicated. Left hand side we have 2 sine squared 45 degrees minus theta. So this is 2 times. Now then the what I will apply here is this formula. I will apply this formula. Okay? I will apply the formula. So that will be 2 times parentheses 1 minus 4 sine blah, right? Cosine twice blah. 2 times 45 degrees minus theta over 2. Do you see that? Let me take care of the 1/2 first. So this is 1 minus cosine 90 degrees minus 2 theta. Oh, duh, this is straightforward. So this is 1 minus sine 2 theta, right? By cofunction. By cofunction. So this is what we have on the right hand side. That's the end of the proof.
Sorry, I lost you after like the second step when you got rid of the 2, both of the 2's.
Or when I what?
So when you multiplied the 2 out, when you foiled the 2.
Foil the 2? No, I don't foil. No, I basically cancel this. These 2 here and these 2 here cancel. 2 times 1/2.
Oh, okay.
Yeah, and then the other thing I did is actually I distribute these 2 by 45 and theta.
Oh, that's all you did. Oh, okay.
Yeah, that's all I did. Okay, now that's for 8.2. Now let's go to 8.3. Now in 8.3, in 8.3 we will apply 2 more groups, 2 important groups. I call them group 4. Group 4 that is product to sum. Product to sum formulas. And later on in group 5, we have, oops, group 5, we have sum to product formula. Now, since I don't prove them for you, but at the same time, then since I don't prove them for you, I don't expect them to memorize them. But at the same time, your test is basically open book as long as you don't tell me, right? Okay, so the focus will be you need to know how to use this formula. Okay, but let me write down the formulas. The first one is cosine A cosine B is equal to 1/2 of cosine sum plus cosine difference. Second, sine A sine B equals to negative 1/2 cosine sum minus cosine difference. If you want the proof, take a look at my trigonometry class videos on chapter 5, I believe. Don't forget there's a minus here. There's a minus here. And then sine A sine B. I'm sorry, sine A cosine B. Sine A cosine B is 1/2 sine sum plus sine difference. And the last one is cosine A sine B equals to 1/2 sine sum minus sine difference. Okay, I think I will do some problem first from here. Okay, at least to give you a good feeling about how to use these formulas. Okay, so for example, if I ask express sine 4x times cosine 2x without power. Or I think I should say as trig functions without power. Yeah, because we have sine times cosine, then that's basically the power of 2, right? Now then, how to express that without power? Then I see sine cosine. Sine cosine, this guy here, match with number 3, right? So that will be 1/2. That will be 1/2 sine 4x cosine 2x equals to 1/2 times sine of the sum plus sine of the difference. So then you will get 1/2 sine 6x plus 1/2 sine 2x. Okay. Okay. Group 5, there are 4. And actually, if you look at the proof that I provided in my trigonometry class, then you will see the first one, the proof for the first one here actually correlates very, very strongly to the proof to that guy. Yeah, correlates very, very, very strongly. They are actually corresponding. Now, then if I have cosine x plus cosine y, okay, that's equals to 2 times cosine half of the sum cosine difference, half of the difference. The second, cosine x minus cosine y will be -2, and make sure that you see that negative, of sine half of sum times half of difference. The third one, sine x plus sine y equals to 2 sine half of sum cosine half of difference. And the last one, difference of signs, sine x minus sine y will be 2 times cosine of half of the sum sine half of the difference. Okay, let's do some problem from our book. For example, let's do, for example, number 24. Number 24, we have cosine 50 degrees minus cosine 10 degrees. Simplify whenever possible. And then we see, oh, this is cosine difference. That's -2 sine of the sum divided by 2, half of the sum, sine half of the difference. This is -2 sine 60 degrees divided by 2, sine 30 degrees, and sine 40 degrees divided by 2, that's 20 degrees. Well, we happen to know that sine 30 degrees is 1/2. So this is equals to negative of sine 20 degrees. How about proving? Like number 38. Number 38, cosine, sine, proof. Sine theta plus b times sine theta minus b equals to sine squared theta minus sine squared b. Proof. I think I'll prove from the left hand side. Sine theta plus phi and sine theta minus phi. How do I do this?
Is it sine A sine B? So like sine zeta sine B?
So that's the
Sine.
product. We'll use product to sum, huh? So right, we'll use product to sum. This one here. I will use this one here. Is it okay?
Yes.
Okay, I will use that one. So this is negative 1/2 cosine sum minus cosine difference. Is it okay?
I didn't know we can do all four at once.
Yeah, just consider this blah and this is blah.
Oh, okay. Okay. Thank you.
Right? So this is blah minus blah. Okay, and then that's negative 1/2 of cosine 2 theta minus cosine 2b. That's equals to negative 1/2. I need sine version, so okay, then I will rewrite it as 1 minus 2 sine squared theta minus 1 minus 2 sine squared b. Negative 1/2 times 1 minus 2 sine squared theta minus 1 plus 2 sine squared b. The 1 cancels, right? So I get negative 1/2 times negative 2 sine squared theta plus 2 sine squared b.
Can we factor out the 2?
Or we can distribute the negative 1/2, right?
Yes.
Yeah, either way you will get the same thing. Okay, which is our right hand side. That's the end of the proof. Okay, now I'm about to give you a break. Together with your break, I want you to do this one problem here, number 40. Number 40. And the question is convert to product. So sine 2 theta plus sine 4 theta plus sine 6 theta plus sine 8 theta. Okay. Actually, for this one, there are many ways to do this. But this question is actually very similar to what you see on number 39. So the idea will be you will combine this and you will combine this. Okay, so use the formulas you have in group 5. This formula from group 5 to combine them. Actually, then you will be able to combine it twice. You combine it and then you have common factor, common factor, common. After you do apply formulas from group 5, factor out common factor, and see what else can be done from there. Okay, let's come back at 6:15. So sine plus sine will give us what? 1/2. Sine plus sine will give us sine half of sum. And then cosine half of difference, right? Plus 1/2 sine half of sum. And then cosine half of difference. Let me simplify it first. I get 1/2 sine 3 theta cosine negative theta plus 1/2 sine 7 theta cosine negative theta.
Hi, Papa.
Okay, then I will factor, actually, let me change that cosine negative theta becomes cosine theta first. So 1/2 sine 3 theta cosine theta plus 1/2 sine 7 theta cosine theta. And then factor the common factor 1/2 cosine theta of sine 3 theta plus sine 7 theta.
Papa.
Okay, hold on, sayang. You want to see my kid, everybody?
Yeah.
Yes.
Hi.
Yes.
Okay. Where's that? Oh, how's that?
Oh my gosh, it's so cute.
Oh, I don't even see where I am. Hold on, stop sharing.
Papa.
Oh,
What are you doing?
come here.
Hi.
So
Come here.
cute. Wait, Professor.
Say hi, everybody.
Hi, everybody.
Hi,
Hey.
little kitty.
How did you become to be so
He cannot listen to you. I don't have the speaker here.
Oh.
Okay, show me your faces.
Yeah.
Hey.
Hi.
Say hi.
Hi.
That's Papa's student. So you need to study hard so that you can be like them. You know?
Aw.
Okay? Okay, go play. Papa needs to go back to teaching.
It's so cute.
Yeah. He is cute until he bothers you. Until he start bothering you. Okay, let's come back here. Now the thing is, I still can apply the same thing here, right? Do you notice that? So this is 1/2 cosine theta times 1/2 of sine half of sum cosine half of difference. So that will be 1/4 cosine theta and sine 5 theta cosine -2 theta, right? And I can take that negative out for free because cosine is even. So it will be cosine theta, cosine 2 theta, sine 5 theta. Okay, well, that's a long one, huh? But that may be useful when we do proofing later on. Okay, that's for 8.3. I think we are pretty much done with 8.3 for important things that I want to go over. Let me ask you to take a look then on page 603 or 604 if there's anything you want me to go over.
Do we have any sort of question that has like 3 tricks that we need to simplify?
3 tricks?
Yeah, like for the proofings.
Oh,
like more than 2 tricks.
That one, I believe our textbook is not enough, but let's see. Let me think where I can get those.
Or something like with a factoring, because like similar to the one that we have in the exam too. Because like at the end of that one in the exam, I had a problem with the factoring.
Which one was that though? Let me see. In the exam?
Yeah. The one with the cotangent and tangent, I think it was. That it equals to secant and cosecant.
Oh, that one. Okay, you want me to show that to you or something similar to that?
Something similar, kind of. More difficult, if you may.
But has something to do with double angles thingy, huh? Yeah.
Yes.
Maybe it's better for me to direct you to the old test I have. And then let's say I pick, I think summer 15. Yeah, summer 15. And then maybe I think what we did here is for test 3. No, not that one. Oh, here, duh. I click on the wrong one. Yeah, so if you take a look on my Math 241, the topic that I covered today and last time actually being covered in test 3, in their test 3, similar to this. Okay, now when you talk about proof, let's use this one here. Let's do this one. Okay, now I told them to use sum to product formula first because, of course, with them and with you supposedly, you're supposed to memorize these formulas, and they didn't have I don't allow them to have cheat sheet. They have to memorize them. But at least I tell them what to use. Okay, let's say we have this question here. Let's say we have this question here, and we want to prove. Okay, now then the proof will be, oops, proof from left to right. Left-hand side, we have cosine 2x minus cosine 4x over sine.
Wait, Professor.
Uh-huh.
I think you can't see the screen. It's still on the
Oh,
on the
my bad,
test.
my bad. Yes. Yeah, here. Sine 4x. And then use the sum to product formula. So cosine minus cosine is cosine minus cosine is I believe negative 1/2. Negative 2. It's negative 2 or negative 1/2. Why am I forgetting? What is the correct formula here? It's supposed to be 2, not 1/2. Now now I remember. Okay, this my bad. Do correction. This is supposed to be 2 here. It should be 2 here. It should be 2 here. 2 here. 2 here. 2 here, and another 2 here. Not 1/4, but 4 instead. Okay. I kind of like got it wrong. Now, good thing I do this problem, otherwise I won't realize my mistake. Okay, come back here. So this will be negative 2 sine half of sum and half sine of half of difference. And then for the bottom one, it will be 2 times sine half of sum cosine half of difference. Let me simplify. This will be negative 2 sine 3x sine negative x over 2 sine 3x cosine negative x. Actually, I can cancel the 2 and the sine 3x already, right? Okay, so I get negative sine negative x over cosine negative x. Is it right?
Yes.
Okay. You can bring the negative out for the sine, or you can just make it negative tangent negative, which is tangent x. That's our right-hand side.
Thank you, Professor.
That's the end of the proof. So if you want to get more material on this, I strongly suggest you to look at my my trigonometry class, my 241 test 3, especially. Okay.
Okay.
Yeah, that's for this section 8.2 and 8.3. Now, I was thinking actually to go over to 8.4, which is solving equation. Then I look at the material, you know what? They basically combine 3 sections in trigonometry into one. And I think it's too heavy for me to finish it in half an hour. So I will jump to 8.5. And after all, in my opinion, they're supposed to do 8.5 first, which is inverse trig function. Inverse trig trigonometry function. Even though I still know that I cannot finish this in full, at least I can do more here. More useful material in this half an hour can be saved. Okay, first I will talk about, the first thing I will talk about is y equals to inverse sine of x, the inverse function of sine. Here's the idea. Now, we know that sine function is not a one-to-one function. Yeah, sine function is not a one-to-one function, and therefore, because it's not one-to-one function, then there's actually no inverse function. We cannot get inverse function. But we can get inverse function only if we restrict the domain. Okay, so let me show you first the graph of the sine. I don't know why my pen doesn't go. Give me a second. The graph of sine function looks like this. Right? That's from 0 to 2 pi. Now, apparently, it's not a one-to-one function. Now, I will try to do some restriction on this sine function such that it becomes a one-to-one function. Okay? Now, the restriction will be done here. The restriction will be done from negative pi over 2 to pi over 2. I'll restrict that here. Okay, let me redraw it. Let me put it here. What happened to my graph? I will redraw it this way. I will center it at the y-intercept. My y-intercept will be placed here. I will put my y-intercept here. And my x-intercept here. Okay. And then my sine graph now becomes something looks like this. This is for the first quadrant, and this is for the second quadrant. Supposed to be the third quadrant, the fourth quadrant, like that. Okay. Now, of course, then following the period, it goes this way. Right. Now, I said that I will restrict the sine function to this region. I will restrict the sine function to between negative pi over 2 to pi over 2. Okay, between negative pi over 2 to pi over 2, the sine function is 1-to-1. Right? The sine function is 1-to-1 in this between negative pi over 2 to pi over 2. So here's the thing. Let me write it down explicitly. To make y equals to sine x to be 1-to-1, by convention, so those people who has lived doing math before us decided, you know what, we restrict the domain to negative pi over 2 to pi over 2. Okay, now I usually call it quadrant -1 and quadrant 1.
Is there any reason why you just pick one? Can't you use like quadrant 3 and 4 and say that is?
The thing is, in quadrant 3 and 4 is not 1-to-1.
Oh, I'm sorry. No, Oh, it's not 1-to-1.
right? This is quadrant 3 and 4 is here, right? It's not 1-to-1. Maybe why not, for example, quadrant 2 and 3, right? Quadrant
Yes,
2
that's
and
what
3.
I meant.
Yeah. Why don't they do that? Of course, they can do that. But if you choose that one, quadrant 2 and 3, you have better reason to do from quadrant negative 1-to-1. Now, the reason is because at least it's closer to origin.
Okay.
Right? It's closer to origin. They have other reason, I believe. But if I have to choose in this between negative pi to pi over 2 to pi over 2, from pi over 2 to 3 pi over 2, or anything before that, of course, the more natural choice will be the one here, right? That's closer to the origin, easier to graph because it's closer to origin. Okay? Yeah, so they have other options, but this is the better option actually for, in their opinion. And of course, you can see that's actually a better option for us. Now, if we see that from unit circle point of view, then quadrant 1 and negative 1 is actually located, in this region here, in this region. You see what I mean? On the unit circle. Okay, and then you will see there's another reason why they prefer that they make that choice. Okay, now so by making it 1-to-1 there, then we define for fx equals to sine x, then the inverse function will be will give quadrant negative 1 or quadrant 1. Thomas, I'm a bit lost. Is it okay? Okay, let's go back to the original function. What is the domain of the original function? Originally, without restriction, the domain is all real numbers, right? But to make it 1-to-1, we restrict that to this interval. Agree? Okay, so in the domain, we have this interval, negative pi over 2 to pi over 2. And using sine function, the outcome will be from negative 1-to-1. Is that right? The range of sine function, even in this restricted domain, is from negative 1-to-1. Agree? Now then sine inverse actually send it back. That's sine inverse function. Okay, it will send it back to quadrant negative 1 and quadrant 1. Now, what does it mean? It means the following. Suppose, for example, suppose I ask, what is sine inverse of 1/2? What is sine inverse of 1/2? The way we think will be as the following: sine what angle? So the question mark, the way we think, sine what angle equals to 1/2? Sine pi over 6 and 5 pi over 6, right? You see what I mean? Now, however, only this guy is in that restricted domain, restricted interval, not this one. You see? Both of them sine pi over 6 is 1/2, and sine 5 pi over 6 is also 1/2. but 5 pi over 6 is not in the interval of negative pi over 2 to pi over 2. Remember, the sine inverse is a function that has to be 1 to 1. So if you have two solutions, you need to choose only one of them. Okay? Now, when we choose only one of them, it has to fall into the interval according to our convention. Okay? And the convention is quadrant negative 1, quadrant 1. Therefore, the solution here will be pi over 6, not 5 pi over 6. Okay? Now, part B. Suppose, for example, what is sine inverse of radical 3 over 2? And you ask yourself, sine what if you radical 3 over 2? There are two angles. The first one is pi over 3, and the other one is 2 pi over 3 in quadrant 2. Okay, but again, if you go back to the restricted interval, you know the answer should be pi over 3 because you need to see restricted interval. Okay. Now, what happens if the value inside is negative? Let's say sine inverse of negative 1/2. Now, this is the benefit of the choice that we used earlier. The benefit of the choice that we used earlier. The reason they chose this, I believe, one of the reasons is they want to utilize, try to take advantage of the fact that sine is an odd function. Therefore, sine inverse also an odd function. Okay, maybe I answer this first. Sine what angle equals to negative 1/2? Then you will say, oh, negative 1/2 will be when theta is 7 pi over 6 or 11 pi over 6. But the problem is neither one of these in the restricted interval though. Neither one of them in the restricted interval. So we look back, hey, you know what? We changed this, which is in quadrant 4. You change that into quadrant negative 1. You use theta equals to negative pi over 6. Okay? So the answer is negative pi over 6, which if you think about it, I basically take benefit of the odd function. So I bring the negative out. Okay, so I can see that as negative sine inverse of 1/2, which is negative pi over 6. That's actually one of the reasons they chose that interval. They chose this restricted interval here because they can, that way they can benefit from that odd function. Okay, so suppose I have what is sine inverse of negative radical 3 over 2. And that will be negative sine inverse of radical 3 over 2, which is negative pi over 3. Okay. Now, the thing is then, how about sine inverse of 1? By the way, I need you to tell me this.
Pi over 2.
That's pi over 2. So how about sine inverse of negative 1?
Negative pi over 2.
Negative pi over 2, that's right. Okay, negative pi over 2. not 3 pi over 2. Even though they are coterminal, but they are not, it is not 3 pi over 2. Okay, it's negative pi over 2. Okay, now that's about sine inverse. Of course, you have to memorize those special value for you to be able to do this type of problem better. Okay, I want to go on with tangent. Tangent has a similar case. Tangent has a similar case. Tangent have the same restricted domain. So the second one for y equals to tangent inverse x. When I get the picture, okay, now they will restrict the domain between negative pi over 2 to pi over 2 also. For what reason? The same reason, because tangent is a negative function, odd function, okay? Because it's an odd function, and between negative pi over 2 to pi over 2, it doesn't. Between negative pi over 2 to pi over 2, it will be 1 to 1. Okay. It doesn't really, well, anyway, let me just make it okay. Let me just make it okay. As long as it is 1 to 1, right? So it looks like approximately like this. Okay, now they restrict that to be between negative pi over 2 up to pi over 2. Okay, so restricted domain or y equals to tangent x to be 1 to 1 is negative pi over 2 to positive pi over 2, not including the endpoints though. As you can see at the endpoints, it becomes undefined, right? Okay, so we don't include the endpoints. But it's very, basically I want to say it's very similar to the way we set up the sine. Okay, now so once it is 1 to 1, then so that we can define y equals to tangent inverse x. Okay, to give the result of tangent inverse x will be from negative pi over 2 to pi over 2. For example, part A, how about tangent inverse of 1? Tangent 1 equals what? I mean, tangent what equals 1? And we will see tangent pi over 4 and 5 pi over 4. But using the idea of the restricted interval again, then the answer should be pi over 4. Okay? Not 5 pi over 4. Likewise, what if I have negative value inside? Tangent inverse of negative radical 3. Tangent inverse of negative radical 3. And that's negative tangent inverse of radical 3, which is negative pi over 3. Now, the thing is for cosine, however, for cosine, y equals to cosine inverse x, the restriction will be in quadrant 1 and quadrant 2. So we know the graph of cosine looks like this. And the graph of cosine looks like this. Okay, so it's 0, pi over 2, pi, 3 pi over 2 pi. Now they will restrict that from 0 degree to pi. Okay, that's the restriction. Restricted domain for cosine y equals to cosine x to be 1 to 1 is from 0 to pi. Okay, now, so the value of that cosine inverse x, whatever the value, whatever the x that you plug in, okay, if it is in the domain of that cosine inverse, then the output will be between 0 to pi. Okay, we can say that's the range of cosine inverse. Okay, because the domain of cosine x is restricted to 0 to pi, then the range of cosine inverse will be the same. Okay, so for example, how about cosine inverse of 1/2? So cosine what equals to 1/2?
Um, 60?
60 degree, pi over 3. Okay. How about if I use negative value inside cosine inverse of negative 1/2? Now we cannot use negative pi over 3 anymore because negative angle is not in the restricted range or coming from the restricted domain. Okay, we cannot say negative pi over 3, but think of the value in quadrant 2. Think of the value in quadrant 2 such that the value is negative 1/2. What is the value here?
Two pi over 3.
2 pi over 3. Okay, it's 2 pi over 3. Okay, now you see that they should have, this A and B here should have the same reference angle, right? One of them in quadrant 1, the other one in quadrant 2. Okay, such that you can actually think of it this way here. For me to do this problem, I can think this way. This is equals to pi minus cosine inverse of 1/2. Okay. Yeah, they have the same reference angle, but if it is positive, it's in quadrant 1. If it's negative, it's in quadrant 2. So I use that idea. Oh, the same reference angle, but in quadrant 2, it must be pi minus that angle. Okay. Now, once we know that thing, then we are able to answer plenty of problem from 8.5. Okay. But the one I want to go over is this type, because I ask this type of question a lot. For example, suppose I have sine, find the exact value Find the exact value of sine of tangent inverse of, let's say, 2. Find the exact value of tangent inverse of 2. Now, 2 is a positive number. 2 is a positive number such that tangent inverse of 2 will be in which quadrant? It must be in quadrant 1, right? Because it's positive. Tangent inverse of positive must be, the angle must be in quadrant 1. If it is negative, it must be in quadrant 2.
But
I mean, quadrant -1, I'm sorry.
but that
Quadrant
is beyond the first quadrant. 2 radians is beyond the first quadrant.
no, that's not in radian. This is not tangent 2, this is tangent inverse 2.
Okay.
Right? Yeah, so tangent what equals to 2, like that. Right? Okay?
Yeah.
So now I will do it this way. I will define, let theta be that angle, tangent inverse of 2. So tangent theta equals to 2. So far, okay? Now then I will construct the right triangle. Well, because again, this angle is in quadrant 1, right? So I can draw the triangle safely. This is 2, this is 1. Therefore, this is square root of 5. Now, if theta equals to tangent inverse of 2, so what we are looking for is actually sine theta. Is it right? You see what I mean? But you can see that sine theta from that triangle already. What is sine theta? over square root of 5, or rationalizing the denominator, 2 radical 5 over 5. Okay, last one. In the last 1 minute, suppose, for example, I ask a cosine of sine inverse of x. Find the expression in terms of x. So the way I do it, just mimic what I did earlier. Solution. Let theta be sine inverse of x. So sine theta is equal to x. Is that right? Let's assume x is positive here. Now then I draw the triangle, the right triangle. If this is the right angle and this is theta, sine theta equals to x, so it's x over 1 here. Then this should be what? Square root of 1 minus x squared. Okay, so cosine theta will be square root of 1 minus x squared over 1. Okay, so if you want to write it even more explicitly, that's the same to say cosine of sine inverse x equals to square root of 1 minus x squared. Okay, suggested homework from here. I'm not done yet. I can do more, but at least I have done most of the thing I want to do. From 8.5, I would like you to do not use calculator from number 1 to number 19. And then number 24 to number, I'm sorry, 25 to number 33. The technique is very similar to what I did earlier. And then think about number 35. Number 35, I think that's all you need. I think that's all you need for this section, actually. Yeah, I think that's all. Okay. Yeah. So on Tuesday when we come back, I will do a bit more problems from here, especially number 35 type, maybe number 36. Okay, or number 43, and then I go on to 8.4. If possible, continue watching the lecture video I asked you to watch for from my trigonometry class. Okay, see you then.
Thank you. Bye, Professor.
Bye-bye.